And remember that your router can be a member of as many autonomous system numbers as you want. You should keep memory in mind, of course. I'm going to make us an autonomous system number of 10. All my routers can have autonomous system 10. They're going to share that information. Network 22.16.0.0. That's all there's to it. Router IGRP and network number. Let's go ahead and telnet into our next router, router A. And let's do the same thing. FigT, router, IGRP10, network, 22.16.0.0. And let's see what we have now. I'm going to do a show IP route. Now, take a look at this for a minute. Let's go over here to the left and look down here. Notice I have my two RIP networks, my two directly connected, and then I have this I. And I'm pretty sure that you can guess that stands for IGRP. Notice here 172.16.10.0. And why did this show up instead of RIP? RIP's still running, and we had RIP here, and now all of a sudden IGRP comes up. Why? Is because of this number right here. This is a more trusted route. RIP is 120. Here's a RIP route, 120. IGRP is 100. This is not a hop count. This is the composite metric of bandwidth and delay of the line. The lower the number, the better. So via 20.1 into my Ethernet 0. Down here, this shows where it's coming into. Here's my composite metric, and notice I have an I here. Now, as I keep going down the lines, let's go ahead and tell it into my next router, and putting it in our RIP network should start disappearing. Notice I'm still using RIP, and it is working on some networks, so notice how they work together. So I'm router B, config T, Todd, router IGRP10, network, and let's take a look at the routing table here. And notice what we have here now. Now I've got network 10 and 20 in IGRP, and only one route, because only one router is running RIP. And notice, because as soon as they find a route with a higher administrative distance, bam, that's going to be replaced. So let's go to our last router. And we're going to turn on IGRP as well. Router IGRP10 network 72.16.0.0. And let's do a show IP route. We shouldn't see any RIP routes any longer. And here we are. Notice I have 3 I's now for all my 10, 20, and 30. Let's go back a router. And the first thing I'm going to do is turn on terminal monitor. Now remember, this terminal monitor command only works for that session, so if I was to exit and get back in, I've typed in terminal monitor again to see my commands. Show IP route. And from here, I see all my networks with IGRP. Type in show IP protocol and see if RIP is still running. Well, there's RIP right there. First thing it says is router RIP, sending updates every 30 seconds. It's RIP version 1, routing for networks. Here I'm 40.2 and 30.1. Notice my gateways here. I have 2 of them here. And RIP, it found a distance of 120. Default is 120, so this is still here. It knows who its neighbors are. It's still transmitting. Just in case, let's go down now, IGRP stops working. It'll then use that route. So it does use that as a backup route, basically, saying, oh, if you know a way to get there. But I have one that's more trustworthy. Why? Because take a look here. Default is 100. Administrative distance is 100. Here's my 2 gateways. They're exactly the same. Redistributing IGRP10, and let's go up here, sending updates. What makes IGRP a little bit better? Sending updates every 90 seconds. Invalid timer, hold down timer, flush timer. And here's my metric weights. These are determined with the bandwidth, delay of the line, maximum transmission unit, reliability, and load. And here's my maximum hop count is 100. It can be set to 255. So it does use a hop count in the sense, kind of like RIP does. And here's my variance is 1 by default, which means basically everyone's equal. So the next one is debug IP IGRP, and we're going to hit a question mark here. And we're going to type in events. And what do we do to make this happen really fast? Because do we really want to wait 90 seconds? So I'm going to say clear IP route asterisk. And let's clear out that routing table and make sure something shows up. I'm going to do a UN space all, turn it off. And basically the transaction is talking about information being sent and received on the interface. Notice there's no routes in here. It's what we'd call a generalized information about, yeah, I'm being sending, received, I'm broadcasting out here, and so on, but I don't see any routes in here. This is just showing me that information is being sent and received on here, and how many are in my updates. Now, my next command, I'm just going to hit my up arrow, and I thought I used a debug command. There it is. And the next one is transactions. I'm going to press enter here. And of course, we want to clear out the routing table to make something happen here. And I'm going to press enter, UN space AL to turn it off. It's not good to keep debugging on, by the way. It does, sometimes I'm in class and someone says the command debug all. And this is, notice what the command that you get. And it certainly will. I've seen some routers actually hose up and you have to turn them off because of so on. And did you see all that information that came by? And I just had it on for a second. Okay, so we were at debug. Let's go back, arrow up to my debug transactions here. And let's take a look at this for a second. A lot of stuff came by in just a second, and really quick too. And notice in my IGRP, this is actually showing my updates and the metric to each one. So the transaction shows our updates, the event shows us a generalized update of IGRP. So it looks like IGRP is running pretty well on our network. Of course, we're going to test this by pinging from to each end. I think 50.2 is in there, right? Yep, that's my switch. And then 10.2. And that seemed to work as well. So our IGRP network is up and running.